Hi all, this is another applications of linear functions example, little profit revenue cost stuff in here just to make sure that people are familiar with that. If you haven't already, it's a good idea to check out the things to know, I think it's called formulas to know PDF that's linked in WAMAP under exam 1 materials. I will expect you to be familiar with some certain types of formulas and applications. So a lot of your basic geometry 2D shapes, I expect you to know perimeter and area for circle, square, rectangle, triangle. I expect you to know your Pythagorean theorem. I expect you to know that distance equals rate times time, and then some of this profit revenue cost. So make sure you look at that. I think I just remembered all of them, but I want you to check that out in case I forgot to mention any. And if I come up with any more, I'll add them to that list. Okay, so this one is, I think, slightly different in that you should be able to come up with your linear equations just by having some knowledge about profit revenue cost as opposed to really having to break it down into points and slopes, although you will see points and slopes in here and we can think about what that means. So, situation here. A company produces rubber ducks. They have fixed yearly costs of $10,000, production cost of 50 cents per duck. The ducks are then sold for $1.50 each, and all but 10% of what they produced are sold. So they don't sell 10% of what they produce, they have some extra. So that adds a little bit of a twist to this one. Okay, so first thing we're supposed to do is find the model for the cost as a function of the number of ducks produced. So snagging some of this out in case it's too little to read, we were told that they have a fixed yearly cost of $10,000. And then they have production costs of 50 cents per duck. Okay, so to find the cost, again, you can go back to a slope-intercept type thinking, but really I think we should just be able to intuitively pick it out of this. If we have $10,000 in fixed costs and then we pay 50 cents per duck to produce the ducks, then our cost, let's go ahead and define some of these variables as well. Let's say C is the cost, and D is the number of ducks produced. Okay, so if we're paying $10,000 fixed costs and 50 cents per duck, basically we just need to take the $10,000 and tack on 50 cents multiplied by the number of ducks. So the 10,000 is just straight up dollars spent. Because the 50 cents is per duck, if we want the total amount of money spent on production, we need to multiply cost per duck times number of ducks. So 10,000 plus 0.5D, and you don't have to tack on the extra zero. You don't need the 0.50D. Okay, so that's our cost function. Revenue function, and here I want to make sure that I'm really clear on some vocab. I don't want to try and force you to learn tons and tons of different applications, but to have some of these handy so that we can ask questions about them, and I can expect you all to be familiar with a little vocab. I've tried to pick out a handful. So revenue versus profit is sometimes a little confusing to people. Profit is revenue minus cost. So basically profit is how much you actually walk away with. Revenue is the total amount that you bring in before considering how much it costs you for production or whatever. So revenue in most situations is going to be a price times quantity. Run out of room there. Okay, so in this case, we know that, let's see, find a model for revenue as the function of number of ducks produced. We are making $1.50 for each duck, but we don't actually sell every duck that we produce. So our revenue, there, let's go ahead and use capital R to match up above. We've already defined what D is, so we'll just stick with that. And I'm going to kind of work my way up to this. If I want the revenue, I know it's $1.50 per duck multiplied by the number of ducks sold, not the number of ducks produced. I'm just giving myself one intermediate step here to figure out what is going on. If I'm supposed to use the variable D, which is number of ducks produced, I need to make sure I adjust that. So I want to say that I get $1.50 for 90% of the ducks I produce. All but 10% are sold. So if 10% of them are not sold, that means 90% are. So if I sell 90% of the ducks produced at $1.50 per duck, this is what I'm getting, which is going to give me what? $1.35. Okay, and I actually think that slope is really interesting. We know that we sell the ducks for $1.50 a piece, and basically what this is saying is if we average that out over all the ducks produced, since we don't actually sell every single duck we make, it ends up averaging out to $1.35 per duck. So we make $1.35 revenue per duck produced. That equates to $1.50 per duck sold, selling 90% of the ducks. Okay, next part, find a model for profit as a function of the number of ducks sold. So if we say P is equal to our profit, this is another one you want to keep in the back of your head. Profit is equal to revenue minus cost. So this is how far ahead we actually end up being. We've already got revenue and cost equations. So we really just need to put those together. If the revenue is $1.35 per duck produced, and then we subtract off our costs, $10,000.50 per duck. This minus sign really does need to distribute, so make sure you end up subtracting the 0.5D, not adding it. So what are we going to get here? P is equal to 0.85D minus 10,000. So basically, if it costs us 50 cents to make a duck, and it averages out to $1.35 in revenue per duck, we're making 85 cents in profit per duck, but we have to make up for the $10,000 before we really start making profit. Okay, part D. Last year, the company made $30,800 in profit. We're supposed to figure out how many ducks were produced. So this is giving us a value of P, profit. We want to plug that into the equation we just found. And solve. So we need to add 10,000. And then we want to divide by 0.85. Which is going to give us 48,000. And again, units are important on these. 48,000 ducks were produced. So if they produce 48,000 ducks, they'll make $30,800 in profit. Okay, last part of this one, how many ducks must be produced this year to break even? Okay, so again, this is somewhat of a vocab thing. Break even means you don't make profit and you don't lose money. You break even, so your profit is zero. You need to just recognize what that means in order to figure out how to set this up. So I'm just going to go ahead and go back to my profit equation and set it equal to 0, but I should point out that another way to think about this is you break even when your revenue is equal to your cost. So you could also go back and set your revenue function equal to your cost function and you would get the exact same answer. I need to add 10,000 to both sides. And then I need to divide by 0.85. I'm just flip-flopping sides here so that I have room to tack on units when I'm all done. This is not required. 10,000 over 0.85. And here we're going to have an approximate. We actually do have to round a little. 11,764.7. 0.71 even is what I get. Okay, so I want to think about this. This is supposed to be number of ducks. So it's not a spot on exact number. So I would be fine with you rounding this here. It's not going to be perfect, but if we do 11,765 ducks, we're going to be really close to breaking even. We'll actually make a tiny little bit of profit, but hardly any. That's as good as we can do. So I do want you to think about if it's reasonable to have a decimal part of a duck or not. And here I would say it is not. So we'll just get as close as possible to breaking even. All right, thanks for watching.